Welcome to Prof.Ahilaa Maths. Plus 2 Mathematics, Tamil Nadu State Board Syllabus. Chapter 1, Application of Matrices and Determinants. Video 1.3, Definition 1.2, Theorem 1.2 and 1.3, Example 1.2 and 1.3. Definition of inverse matrix of a square matrix. Just recall. Let capital A be a square matrix of order n if there exists a square matrix capital B of order n such that AB equal to BA equal to IN, then the matrix capital B is called the inverse of A. Simply saying, if AB equal to BA equal to I, then B is called the inverse of A. Remember this one strongly. Usually we denote the inverse of an A matrix as A inverse. So A into A inverse equal to A inverse into A equal to IN. So here we write in terms of A itself, okay? Clear? Good. Theorem 1.2. If a square matrix has an inverse, then it is unique. See the steps and the corresponding reason. Let us consider a square matrix of order n such that A inverse exists. Now we need to prove this A inverse is unique. We prove this by contradiction method. So we assume the thing in the converse. Okay. So conversely, let there be two inverses for A, say capital B and C. So you know the definition for inverse of any matrix. Suppose B is the inverse of A, then we write AB equal to BA equal to IN, the identity matrix of order n. And C is the inverse of A means we write AC equal to CA equal to IN. Keep these as equation 1 and 2. Now consider C, the matrix C. We know multiplying by the unit matrix we get the same matrix. So we can replace C as C into IN. Instead of this IN, just use equation 1 AB. So we get C into AB. We know matrix multiplication is associative. So we associate CA first. So CA into B. Now by equation 2, the CA equal to again IN. Again we get IN into B equal to B. Now what we have got means C equal to B. So we say these two inverses A, B and C are the same. So that inverse of a matrix is always unique. Clear? Theorem 1.3. Let capital A be square matrix of order n, then A inverse exists if and only if A is non-singular. So let us take the square matrix capital A of order n as common. Here it is if and only if. So it contains two parts, okay? If part and implied by part. We prove by two cases. See the steps. Case 1, if part. Commonly we consider capital A be a square matrix of order n. In the if part, we consider A inverse exists. That is as the given condition. So A inverse exists means by the definition we can say A into A inverse equal to A inverse into A equal to IN. Keep this as equation 1. Now we need to prove A is non-singular. You know the definition of non-singular, that is to prove determinant A not equal to 0. For this we take determinant throughout the equation 1. So it becomes determinant A into A inverse equal to determinant A inverse into A equal to determinant IN. We know the property of determinant. Determinant AB equal to determinant A into determinant B. And determinant IN equal to 1. Apply these two properties in the equation. So we will be getting determinant A into determinant A inverse equal to determinant A inverse into determinant A equal to determinant In, which is equal to 1, and we know 1 is a non-zero value. So that the product of two non-zero numbers will be a non-zero one. So, okay. So, we can say clearly that determinant A not equal to 0. Since the product determinant A inverse and determinant A brings out a non-zero value, both these determinants will be non-zero. So, determinant A not equal to 0 and A is non-singular. Case 2. Implied by part. Let A be non-singular and we need to prove A inverse exists. A non-singular means by definition we know determinant A not equal to 0. We need to prove A inverse exists. Now remember the theorem 1.1. We know A into Aj equal to Aj into A equal to determinant A into In. So divide throughout by determinant A. Bring this division close with Aj. Okay. So combine Aj by determinant A because as per the formula of A inverse, you remember. So A into Aj by determinant A equal to Aj by determinant A into A equal to In. So by definition of inverse of a matrix, we know something multiplied with the A matrix gives a unit matrix. So that something matrix should be the inverse of A. Okay. So this something matrix we consider that as B. So B equal to Aj by determinant A. So that we are getting AB equal to BA equal to In. Thus we conclude that A inverse exists. Therefore A inverse exists if and only if A is non-singular. Clear? Good. To get the adjoint of a 2 by 2 matrix or square matrix of order 2. Let capital A equal to A11, A12, A21, A22, a 2 by 2 matrix. Now step 1. Interchange the main diagonal elements, that is interchange A11 and A22. That is, see, the highlighted elements are getting interchanged. Step 2. Change the signs of the other two elements. So what are the other two elements? A12 and A21. We replace A12 by minus A12 and A21 by minus A21. See? So what will be our Aj? So apply the two steps successively so that we will be getting Aj equal to A22 minus A12 minus A21 A11. Remember, step 1 is interchange the main diagonal elements. Step 2, change the signs of the other elements. Example 1.2. If capital A equal to ABCD is non-singular, find A inverse. So given a 2 by 2 matrix and it is given it is non-singular, we need to get the inverse of that matrix. So given capital A equal to ABCD, and you remember the formula A inverse equal to 1 by determinant A into Aj. So we need to get the value of determinant A and Aj. So determinant A equal to product of the main diagonal elements minus the product of other two. So AD minus CB. So what is Aj? Remember the steps. Step 1, interchange the main diagonal elements. Step 2, change the sign of the other two elements. So what are the main diagonal elements? A, D. We interchange these two and change the sign of the other two elements B and C, that is minus B minus C. So what will be your Aj? D minus B minus C, A. So apply in the formula A inverse equal to 1 by determinant A, that is AD minus CB into Aj, that matrix D minus B minus C, A. So remember, here we need to get determinant A value and it is given in the question that it is non-singular, so we no need to check for non-zero value. Okay, it is given. So A inverse exists. Got it? Now example 1.3. Find the inverse of the matrix 2 minus 1 3 minus 5 3 1 minus 3 2 3. So 3 by 3 square matrix. given A matrix. Here I again remember the formula of A inverse equal to 1 by determinant A into Eg. I hope you remember the steps we need to follow for finding determinant A and Eg. Okay, you know Eg equal to the transpose of the cofactor matrix, and I get the determinant value by expanding by the first row. So this is the determinant A value. So we are getting determinant A not minus 1, which is a non-zero value. So we confirm that A inverse exists. Now we know that A inverse equal to 1 by determinant A into Eg, and we know Eg equal to transpose of cofactor matrix. So see Eg, you replace each element by the cofactor element, okay? So we are getting these values, and the transpose of this matrix will get you the Eg. So the transpose, simplify each element. Suppose see the first value plus determinant 3 1 1 2 3. I am getting the value as 3 into 3 9 minus 2, that is 7. Similarly get all the values and transpose the matrix. The transpose will be 7 9 minus 10 12 15 minus 17 minus 1 minus 1 1. So this is Eg. Now substitute in the formula. A inverse equal to 1 by determinant A into Eg equal to determinant A, we got it as minus 1. So 1 by minus 1 into the Eg matrix. So since 1 by minus 1 is minus 1, we just change all the elements sign. Okay. Good. Now my dear children, the next assignment 1.1 is, I request you to solve exercise 1.1 first and second questions. Both the questions contain 3 problems. So find the adjoint of the following. First one is 2 by 2 matrix and the rest 3 by 3 matrix. Find the inverse of the following. So within bracket they have given if it exists. Inverse exists only for non-singular matrices. So first of all you need to check for non-singularity, that is determinant A not equal to 0 condition. Once it holds, then inverse exists. Suppose determinant A goes 0, you simply say A inverse, that matrix inverse does not exist. Okay, please try each and every problem of these, that is 6 problems. So video 1.4 contents, just we are going to discuss the assignment 1.1 solutions. Okay, stay tuned, success is ours. Thank you.